Hi, everyone. Today, what we're going to work our way through is our first day of compiling, putting together all of our transformations. So, the position we should be in today is we should be feeling pretty comfortable to deal with each individual transformation on its own. So that today really just becomes a cumulative day. So the focus for today isn't how we deal with a particular transformation. My assumption is you're good with all of them. But rather, how do we talk about putting them all together, and what are some issues that may arise when we do? So we've got a little bit of a note to get down first before we jump into the handout note. So on a blank piece of paper in your notes, I'd like you to get down that big ugly function up top. Now, if we start to piece together, that's about as ugly of a function as I could throw at you. So you'll notice that you have your y equals f of x worked in there in purple, but now I've put in an a value, a b value, a c value, and a d value. And there aren't any particular letters, like it's not like, well, the a is this, the b is this, and so on, and that we need to use those variables to represent those. They're just like placeholders for missing values. Below that, I'm going to give you my advice as to how we should go through and deal with our transformations. Now, there's several different ways to look at this. And I want to make sure that we're comfortable that there are different ways to perform our operations. I'm just going to go through what would be my suggestion to you. Okay, what you have is my suggestion in purple. The reason for that is because then you don't need to learn anything new. That you already have that in your back pocket. You guys all have BEDMAS, our order of operations, that we've been working through. That if we just follow BEDMAS, then we should be good. Now, you might start to think, okay, transformations, how is that BEDMAS? But really what I'm talking about is the operation that attaches that to our function. So when we scan up in our big ugly function, we see that we've got A, B, C, and D, and we notice that A and B are attached by multiply, where C and D are attached by add or subtract. And so when we make reference to follow BEDMAS, follow our order of operations, we clearly have to do multiply before we do add or subtract, and that's what's going to drive the order of our transformations. So you'll notice in my list then below there, I really have two number ones. Because our stretches and reflections are both attached by multiply. I stretch as a factor, but then if that was a negative value, then I have a reflection and an axis. They're both attached by multiply, and it never matters what order I multiply in. We should be good to see then you could perform your stretch first and then your reflection, or you could do your reflection first and then your stretch. That these two happen to be interchangeable. And you'll notice that I don't really follow a pattern where I always do a stretch first and then I do a reflection or vice versa. I tend to be a little lazy with my transformations, and I'll show you what I'm talking about as we come up. Lastly, according to BEDMAS, we know we always have to do our add or subtract at the end. Translations or shifts are attached by add or subtract. So as long as I'm doing my add or subtract, my shifts at the end, then I am good. Now, there are a couple other ways that people tend to remember that. And maybe, if you go to your tutor or you're looking in some old textbook, you might see the acronym SRT. And some people kind of learn their transformations through that acronym. The only reason I'm addressing that is just because in case you hear it and you go like, oh, this is like something new, that's what I use. Can I just get you to see that really SRT is our acronym for our order of operations? SRT is just do your stretches, then your reflections, then your translations. Notice it is our order. But sometimes people end up hearing SRT from somewhere and they think it's this brand new easier thing to do because it's got this little acronym. It's the same thing. The last thing that I maybe want to focus in on is there is another order for us to be able to do our transformations. I'm just going to maybe warn you about it a little bit. That we can do our transformations if we follow a certain pattern that just deals with everything vertical and everything horizontal. Or everything horizontal and then everything vertical. That we can transform our graph and have the proper outcome to our graph if we deal with all of our vertical transformations and then all of our horizontal transformations, or vice versa, as long as we don't switch in between. So an example might be where I do a vertical stretch, then I shift it to the right 2. Then I go through and do a horizontal stretch. Then I shift it down. Where I'm bouncing back and forth between my vertical and my horizontal transformations. I'm going to warn you against that one a little bit because it does increase a risk for mistake. That my biggest suggestion to you is follow order of operations. It's the easiest way to get there. Okay, I'm going to show you some of those other ways as well, or I guess the vertical versus horizontal way later on. But I think that our first step should be, can we get down a way that we can produce that graph? Okay, we got a little bit more of a note to take down. Down below what you just wrote down, we're going to add in something a little bit more. So what I've put up there is about as ugly of a function as I could give you. You'll notice that I've replaced my A, B, C, and D with values. What I'm also going to ask you to do is leave a couple lines blank underneath that big ugly function in purple before we start getting down a list of transformations. Okay, I don't think that this would take any practice. I'm assuming that we're good on all of this. This is why I'm asking us to just copy down this note as like an ugly example. If I was to examine my purple function, then I'm going to look at my things that are attached by multiply first. I'm going to follow order of operations. Okay, number 1, I notice that my -2 out in front is negative, so I have a reflection in the x-axis. That 2 out in front is a vertical stretch by a factor of 2. And remember, we always state the result of our graph, so therefore it's steeper. I jump to the inside value that's attached by multiply, and I notice that it's negative, so I have a reflection in the y-axis. And since I'm multiplying, I have a horizontal stretch by a factor of, and I need to remember that I've got that opposite operation there, so by a factor of 3. If I stretch it horizontally by a factor of 3, my resulting graph is going to be flatter. Okay. Those 4 transformations could have all been done in any order. They are all attached by multiply. And so as long as I deal with those 4 in any particular order first, then I'm good. Okay, I jump down to the last. I notice that I have my shift right 1 from the -1 on the inside, and a shift down 4 from my -4 at the end. There are all the transformations that I would have to do to one function because of that purple equation. Now, there's a couple things that I just want to draw your attention to. The first thing that I want to highlight is how we address this -1/3 that's attached by multiply on the inside of our function. That as we've kind of progressed, we haven't had to put our transformations together yet. But as soon as we start to combine transformations, there could be a bit of an issue. I'm going to rewrite out that function in a different form. that what I may have on the inside of my brackets is that negative 1/3 multiplied into the bracket. So I want you to notice all I did was expand in the negative 1/3 into the x minus 1. Okay, look at the orange equation that I've given you now. And I want you to see your trap. Just because I expanded in the negative 1/3, my purple equation is the same as my orange equation, yet if I were to ask you to interpret your transformations, you're probably going to give me an incorrect horizontal shift. You would probably tell me that we're shifting our graph to the left 1/3 now. Okay, clearly we can't have a different transformation just because we chose to write the equation in a different form. It's still the same function. So what happens if you are given the orange equation? You would then have to factor out that stretch factor value from everything on the inside of the function. So can you picture factoring out the negative 1/3 inside your bracket and being left with an x minus 1? Okay, I'm hoping that we can see that. It's important for us to note that our stretch factor must be multiplied by everything on the inside of our function in order to interpret our horizontal shift correctly. Okay, easily your number one trap, not even close. Now, the second thing that I want to talk about is that sometimes, because we happen to see our equations in the form written in purple, that we just start to deal with all of our transformations moving left to right. And I want you to notice when you look at the purple, if you do move left to right, we follow order of operations. However, don't be trapped. I could give you the function in this form with that -4 written out in front. It's not like that -4 now is all of a sudden a stretch because we've put some idea in our mind that the number out in front is our vertical stretch. No, it's about the operation that attaches it. But also that because it's written out in front, that we have to do that transformation first. If we see that that's a -4 on the outside of our function and therefore we have to shift it down 4, we know we have to do our shifts at the end. So let's make sure that we don't put any ideas in mind that, oh, well, we always go left to right. No, we follow our order of operations. It might feel like quite often we go left to right just because of the form we see these functions in. But let's make sure that we're always looking at what operation attaches the value to the function. Okay, I think we've got a lot of theory now that we've just walked through. Let's jump in and let's start getting some practice. Let's start using it. So what I'm going to ask you to do is jump over onto the handout page for our lesson. Okay, so what you see at the top of your page is a graph on your grid. I've put it in red. There's your y equals f of x. What you'll also see, and what I would like you to copy down in that space that I gave you, is your big, ugly function. So there is as ugly as it could be. Could have a stretch factor, vertically and horizontally. They could be negative, so that means that also includes reflections. And we could have shifts horizontally or vertically. Okay, what I want to do is I want to start off with just a graph that we don't have to worry about the equation to. So look at the picture in the top right corner. That is our graph of f of x. And now what I want to do on the next 3 problems is I want to work our way through how do we graph the new transformed function. Okay, here we go. So what you see in problem A, B, and C are 3 transformed functions. 3 changes to the graph of f of x. And what we're going to do now is we're going to go through and interpret those equations and now produce our new function. So I am not going to ask you to do this unless the problem explicitly tells you to. And nowhere in the problem does it tell you to write out the transformations. I'm just going to do it for this first equation. That we should be good to be able to see the 2 up in our equation and say that we recognize that that's on the outside, so it's vertical. It's attached by multiply, so it is a stretch. So I have a vertical stretch by a factor of 2. We also notice that we have the -3 on the inside. That -3, it's attached by a subtraction, so that is a shift. It's on the inside, so it's horizontal. And I know that that means that I have to shift it right 3 units. Now, what I want to talk to you about, and it was mentioned in a previous topic, the idea of using intermediate graphs. That rather than doing both of those transformations at the same time, we just might not be there yet. And I need you to know that you're okay to use intermediate graphs. The issue becomes, if you choose to use intermediate graphs, we have to make sure that we label the graph so that the reader understands where your function is coming from and which function is which. So let's imagine that this one, A, I'm going to use intermediate graphs because this is still pretty new to me. Well, then I'm going to deal with the blue first. I'm going to take my graph and I'm going to vertically stretch it by a factor of 2. So all of my points are going to become double vertically. Double the distance from the x-axis. So my first key point gets doubled. My next key point is on the x-axis, so it's not going to move. It's invariant. My next key point gets doubled, and my last key point gets doubled. I'm now going to connect those points to produce my transformed graph. As I'm connecting them, clearly that isn't our final graph because we haven't dealt with all of the transformations. But especially early, we may feel not as confident to just go one graph. Now, me doing that vertical stretch by a factor of 2 means that that blue graph is only 2 f of x. Okay, now what I can do is I can create my green graph. I'm going to put my final transformation in there. I now need to take the blue and I need to shift it right 3 units. So I'm going to take all my key points and shift them 3 units to the right. Now, we know that anytime we shift, our shape doesn't change. My last key point is off my grid. So all we should be doing is taking the exact same shape that we see in blue and moving it, shifting it. I can now see that the next portion of my function should just be a horizontal line, so I'm going to extend that until the end of my grid and stop. There is my final graph. That graph needs a label at now 2 f of x minus 3. There we go. So there's our first graph where we've actually gone through and dealt with multiple transformations, different transformations within one function. Okay, what I want to do is I want to jump into the next one. And what I'd like to do is try to do it without intermediate graphs. Now, I understand that this is still relatively new for all of us. So what I might argue to you is interpret the transformations you see in equation B, and I would like you to go through and use an intermediate graph. So maybe we start by just saying, let's write down the transformations underneath the graph like we did in A, and then we'll stop doing this for each question. Okay, pause the video now. Okay, we're back. So we're going to end up dealing with everything together, but we should have recognized that we had the negative out in front of the F attached by multiply. So we know that that's a reflection. It's outside, so that means vertical. So if I reflect something vertically, it has to go across the x-axis. So we have a reflection in the x-axis. Then we notice the next two things happen to be attached by adding, so that means we know that we've got a shift. So I can make that statement at the same time. I'm going to shift left 1 unit and up 2 units. And there we go. So hopefully you interpreted what you had in that function, in the equation properly, and now we're able to go through and produce our picture. So what I want you to do, produce your graph, but just use an intermediate graph. So maybe we deal with the reflection unto itself, then we deal with the shifts. So let's deal with it as 2 graphs. Okay, pause the video now. Okay, we're back. So I'm going to go through and jump straight to the final graph. You're just going to see me maybe write some stuff down that I wouldn't normally, just to make the video run a little smoother with you at home. So the first thing I would do is I'm going to go through and I'm going to reflect my graph across the x-axis. So I happen to see that my first key point is 1 above. It gets transformed to 1 below. Now I can immediately shift that point. So let's shift it left 1 unit and up 2 units. There's my finishing position. So I should be able to go straight to the purple and not write down the blue. Okay, I would take my next key point. Well, it's already on the x-axis, so if I reflect it across the x-axis, it doesn't move. So I just need to shift that left 1 and up 2. Take my next key point, 3 above the x-axis, reflect it, puts me 3 below. Now shift it, left 1, up 2, and so on and so on. We should be good to be able to reflect, left 1, up 2, and come in on our final graph. What I would notice for some people, though, is that this is where attaching your points at the end might start to get a little more complex. Oops, I've got my eraser on. That as we go through, something different is happening. That as we address multiple transformations, some of those transformations being a stretch or a reflection, that we are going to notice that our shape changes. And because our shape changes, we may find it a little more difficult to connect those in the same order because it doesn't pop out to our eyes. Hopefully that's the graph that you have and we match up with your final graph. Okay, a couple quick things that I just want to make a note of. Now that we can start to tie some stuff together, we know that shifting a curve doesn't change its shape. However, reflecting a curve does. Notice that in every instance on my original red graph, where my graph was decreasing, so that means it was falling to the right. Let's take this first little interval. It's now switched to be an increasing graph. I'm going to get rid of those highlights. Wherever my graph was increasing, I notice that my new graph is now decreasing. So me reflecting my graph is going to change my increase and my decrease. However, that when we have no change, that is, it is neither increasing nor decreasing, like in that horizontal section, then when I reflect a horizontal section, I still get a horizontal section. So there is some stuff that allows me to go through and confidently connect those points. Okay, I want us to take a look at C now, because I'm going to call problem C a trap question for you. And I've used that term trap already today. That maybe you can see in the original equation why it's the trap. I am hoping that when you take a look at that original equation, that negative out in front of your x is screaming at you. Remember that whatever our value is that's attached to x by multiply, so whatever the coefficient on x is, has to be applied to everything on the inside of the function. The other way to think about that is your coefficient on x has to be 1 on the inside of the function. So as we go to jump in and begin that problem, we have to make sure that we're good, that in order to interpret our shift correctly, horizontally, we have to factor out that -1 from everything on the inside of the function. Our common mistake, that trap, would have been to view the original equation in C and say, oh, that's a shift left 1. When now you can see that really that should be a shift to the right 1 unit. Okay, now that I've given you your adjusted equation, I want you to go ahead and try to deal with it all in one go. Okay, start to finish. I want one graph on your page, no intermediate graphs. Interpret those transformations and we'll see if we match up. Okay, pause it now. Okay, we're back. So we should be good to be able to interpret everything in the equation. And I'm just going to go following order of operations. I've got the negative out in front. That's on the inside of my function, so I need to reflect that horizontally. I'm reflecting across my y-axis. Then I can interpret my 2 shifts. I'm shifting to the right 1 and down 2. So if I take my first key point and I reflect it across the y-axis, it's coming all the way over there. Now I would shift that to the right 1 and down 2. There is my finishing position of my first key point. So that's going to give us just something to be able to check against right now. And if we need to make an adjustment, pause the video, finish it off, come back and see if we match up. Okay, I can now reflect my second key point, shift it to the right 1, down 2, puts me to here. My next key point is on the y-axis. So if I reflect it across the y-axis, it's invariant. All I can do is shift it right 1, down 2. My last key point is 5 units to the right, so reflect it becomes 5 units to the left, right 1, down 2. And if I do a quick check, reflecting is going to change, increasing to decreasing, vice versa. And there were no stretches, so all my slopes should be the same. That if I now went through to connect all of my points, then I have that small little segment there. I'm coming up there. And now I have my horizontal section here. Hopefully we match up. So there we go. Now, the last part, I've been drawing on some pretty big key points on my final graph. I'm going to stop doing that so much. I was just doing that on these graphs to really allow those to pop to you through a video lesson. As we start to work our way through, hopefully you don't have big, huge dots like that when we go to graph a specific function. Okay, let's jump into problem 2 at the bottom of the page. So we've got a couple things that I need you to do. So first off, pause the video, give that whole problem a read. Okay, pause it now. Okay, we're back. So the first thing that we should recognize, and I'm just going to highlight that in purple, we need to draw the graph. So for each one of these, we're going to put that graph on our page, on the grid. But then the second thing we need to do is we have to state domain and range for each. So down below each grid, we're going to add in our domain and our range for each function. Okay. Well, the first thing we notice is we have to graph f of x equals root x. So there's our good old square root function. So my recommendation to you, at least for this first graph, why don't we go ahead and put on our base function? So I would expect us to be able to put our base function on in like 10 seconds. So I want you to go ahead and put root x onto your first grid. Okay, pause it now. Okay, we're back. So we should know that one cold. 0, 0, 1, 1, 4, 2, connect with a smooth curve. There we go. That is y equals root x. If I wanted to use the same notation in my original, I could have labeled that as f of x. Okay, now what I've been asked to go through and graph is y equals f of x minus 1 plus 2. And some of us might be a little confused as to how to deal with that because now we're seeing a mixture of notations. Just a little reminder, remember, f is our square root function, so I can replace my f with my square root function. Whatever was on the inside of f has to be on the inside of my square root. Whatever was on the outside must be outside. And we come in on that equation. Okay, now we can see what's different in the equation, and I would like you to go ahead and graph the transformed curve. Okay, pause it now. Okay, we're back. So I hope you noticed that we can use our key points to go through and deal with those transformations. So we notice the transformations in the equation tells us to shift the graph to the right one and shift it up 2. So I can take each of my 3 key points and shift them to the right one and up 2. So my first key point to the right one, up 2. My next key point to the right one, up 2. My next key point to the right one, up 2. And I get those 3 really big points. Now, I told you that I wasn't going to make my points quite so big anymore. But that's where my points lie. Okay, now I'm going to connect those points and produce my transform curve. You'll notice I put an arrow on the end because I know that that curve goes on forever and ever off the grid. So I need to make sure that I put the arrow to show that. Now I can go ahead and I can label that as my y equals root x minus 1 plus 2. There we go. Okay, let's jump into the second part of the question. We've been asked to determine domain and range. Well, I want to tackle this 2 different ways. Now that we see the picture, we should be good to be able to state our domain and range and have it be automatic. If I look at my purple graph, that graph exists wherever x equals 1 and for any x values that are bigger. So x must be greater than or equal to 1. I notice that that purple graph exists for any y values that are 2 and bigger. So y must be greater than or equal to 2. Okay, we can figure out our domain and range from a picture pretty easily. But what if I didn't give you the picture? So now what I want us to do is let's look at the equation of the graph. The first thing I would notice, if we're going through to find domain, we know domain are possible x values. Well, where is our x? It's underneath the root. And I know whatever is underneath the root must be positive or 0. So I can ask myself, well, what makes it 0 underneath? It's 1. If I sub in an x value of 1, then I'm going to get 0 underneath my root. If I sub in any x values less than 1, I'm going to get negatives underneath my root, and I cannot calculate that. If I sub in anything bigger than 1, then I can calculate that. Therefore, my x must be greater than or equal to 1. We can see it from our equation. Okay, it's a little more difficult to determine range because we're talking about outputs now. But the way we can think about it is to think about our root in its entirety. I boxed that in green because I want you to think about it as your base green graph. What is the smallest value that a square root function can give you? Our base square root function, the smallest value it can give is 0. As soon as there is any other number that's underneath that root, it's at least going to give me like a bit. And so maybe I can see that that boxed in value at the smallest will be 0, or it'll at least be bits. So my range then is going to be the 2 at a minimum, if it was 2 plus 0. Or bigger than 2 if it's going to be 2 plus those bits. And therefore, my range is y is greater than or equal to 2. Okay, hopefully not too bad, but I would say definitely more difficult to deal with just the equation as opposed to the graph. Okay, I want us to be able to work through B and C. So what I'm going to ask you to do is I want you first to go through and deal with the graph. Feel free to go and put on your base function again, but also feel free not to include it. If you know your base function cold enough, then just transform your 3 points. Don't fill in domain and range yet. Let's get a little confirmation on our picture. Okay, so I want you to go ahead and produce the graph for B. Okay, pause it now. Okay, we're back. So the first thing, and some of you guys are going to want to scream at this as you go, is I'm going to bet and say some of us made a mistake interpreting our transformations. Take a look at your coefficient on your x and notice that it's not 1. If I was to take that equation and just rearrange it and put it in a form where we may go, oh, okay, my x was first, then my constant, then you might see that this looks an awful lot like question 1C. That I need to go through and I need to factor out that -1 from everything inside my function. And so our common mistake would have been that we would have thought that we should have been shifting that graph left to, and now in purple you see, oh, it should have been a shift right to. Okay, I'm going to give anybody who's had a chance, or who maybe who made that mistake, to go back and correct their graph. Okay, do that now, pause it, otherwise we're going to finish off the graph. Okay, so we're going to work our way through. I don't need to put on my base function. What I am going to do, though, is to just put on the green point to highlight which point I am transforming. So I'm going to take my first key point at 0, 0. And look at all the transformations I need to do. I need to go through, reflect that point in the x-axis, then reflect it in the y-axis, shift it to the right 2, shift it down 3. So there's my process. Now, the nice part is it's on the origin. So if I reflect that in the x-axis and I reflect it in the y-axis, it doesn't move. The only transformations that are going to affect that is a shift right 2, down 3. There's my finishing position of that first key point. Okay, I'm going to get rid of that green key point because now I'm going to move to my next key point. So now I'm going to focus in on transforming 1, 1. Okay, I need to now reflect that in the x-axis. That's going to get me to that position. I now need to reflect that in the y-axis. That gets me to that position. We could have reflected it in the other order because we can do any reflections in any order we like. Notice if we reflect it in the y, then the x, we get to the same position. Now I need to shift that to the right 2 and down 3. And I get to there as my finishing position. Okay, I can get rid of all of that stuff. And now we're going to the last key point. That point being at 4, 2. Okay, I'm going to deal with my reflections. Reflect it across the x. Now across the y. Shift it to the right 2, down 3. And I come in on that position. Hopefully we match up. And now we can connect those with the shape. I level off and I get something like that. There we go. Hopefully not too bad. Okay, now that we have that, I want you to finish off the problem. Go ahead and state domain and range. So down below, find domain and range. Pause it now. Okay, we should be good. We take a look at that graph and we see that our x values have to always be less than or equal to, I hate that 2, that's to 2. We can also look back up into the original equation and notice that if your x value was less than 2, we're going to have negatives. Or sorry, when your x value is less than 2, we will have positives on the inside. Anything larger than 2 would create a negative inside our function. Our range, we should be good that our y values have to be less than or equal to -3. Okay, hopefully not too bad. Now, I want us to jump in to graph C. That's a pretty ugly function. We should be good to be able to go through. No one's going to fall into any traps. So I'd like you to go start to finish. If you have to manipulate the equation of the function, manipulate it. I want you to go ahead and graph the function given, and I want you to state domain and range. Okay, so we're going to knock this one out in its entirety. Okay, pause it now. Okay, we're back. So hopefully we recognized that we're going to have to do a little manipulation of that equation. I have a -2 that is on the inside that I need to factor out to make sure that it's multiplied by everything. Now I see my equation. I am good to interpret that. I'm going to highlight the stuff as we move across. The first thing I notice is I've got my negative out in front, reflected across the x. I notice that I have a 2 out in front. So I have a vertical stretch by a factor of 2. I notice I have a negative multiplied on the inside. So I need to reflect that across my y. I have the 2 on the inside. I need to remember that that is a horizontal stretch by a factor of 1/2. Remember, it's always that opposite operation. Make sure we didn't fall into that trap. And then the easier parts, shift it to the right 1, shift it up 3. Okay, we're going to go ahead and do the same thing as what we did before. There's my first key point on my square root function. Now I'm going to transform it. Reflect it across the x-axis, causes no change. Vertically stretch it by a factor of 2 from the x-axis, means it's not going to move anywhere. Reflect it across the y-axis, no effect. Stretch it horizontally by a factor of 1/2, no effect. All of my stretches and reflections are not going to affect any point that's on the origin. So the only thing that happens is I shift it to the right 1 and up 3. There's my finishing position. Hopefully we match. Now I've got my next key point, 1, 1. Okay, this point is going to move. So first thing I can do, reflect it across the x-axis. Now I'm going to vertically stretch it by a factor of 2. I'm going to just put that x really big because I want us to see what I had mentioned at the very beginning about going through and sometimes taking a different order with how I treat reflections and stretches. I tend to find myself being lazy. Like I almost view some transformations as if it was physical work. So this would be an instance where I wouldn't vertically stretch it first and then reflect it, because I would view it as like more work. Look at my finishing position where I am just after those vertical stretch and reflection. I'm at 1, -2. See, I would view this a little bit differently if I was like, okay, so now I'm going to vertically stretch it by a factor of 2. Now reflect it, and I have to go like, oh, now it's 2 units above the x-axis, so 2 units below the y. Oh, that was so much extra work. As opposed to just reflecting it the short distance and then stretching it again. I know it doesn't make any sense the way I view it that way, but it's just how I view it. So as I work my way through, reflect it, stretch it, brings me to here. Now I need to reflect that across the y-axis. And now I need to do a horizontal stretch by a factor of 1/2. That means that that point is going to go to half the distance to the y-axis. I'm not finished because I haven't shifted it yet, but I just want you to notice that now I need to estimate where I am on my grid. Okay, now I need to shift it to the right one, which puts me here, and up 3. 1, 2, 3. My finishing position is right in the middle. I would be at the point 1/2, 1. Okay, I can get rid of that. And that green point. Okay, if we made an error as we were working our way through, then what I'm going to ask you to do is to take 4, 2 and try that one on your own. Okay, pause the video now. Okay, we're back. So here we go. Reflect it, vertically double it. Now reflect that across the y-axis, and now horizontal stretch by a factor of 1/2 puts me halfway. Shift it to the right one and up 3. There is my finishing position, and we are good. Okay, that I think is the best way for us to go through and transform our stuff. Now you could go ahead and you could connect those with your smooth curve. And now we should be getting a little flatter as we continue. There we go. Okay, we should be good to fill in domain and range. We notice that our domain, x has to be less than or equal to 1. That's where my purple graph exists. And my range, my y value has to be less than or equal to 3. There we go. Okay, hopefully not too bad, and we're starting to see how we can put all this stuff together. Your job, jump in and get a bunch of practice with this. Make sure that we're good on the order in which we need to deal with our transformations, but then we can actually execute that, both with a generic function and with one of our background knowledge functions, one of our base functions. Okay, best of luck.